When you're conducting a probability experiment, most of the time it's pretty easy to tell whether the two events are independent or dependent. So for example, if I have chips in a bucket and I take one out and I don't put it back in, that probability of the second draw is going to be influenced by what I picked out the first time. So without replacement is considered a dependent event. If I put the chip back, then the second probability isn't influenced by the first, it is an independent event. Now, not only can events in a probability experiment be independent or dependent, so can events or variables that occur in real-world situations. So we're going to take a look at today, how do you tell whether two variables or two events are independent from each other? One option for you is to check your independent probability equation. Does the probability of A times the probability of B equal the probability of A and B? Or your other option is to check to see if the probability of A given B is the same as the probability of A. So for example, knowing B hasn't influenced A at all. So let's put this into play in your college problem down below. Since we are given the probability of Cornell, the probability of Ithaca, and also the probability of being accepted at both colleges, let's use the first equation, the independent event equation. So let's see if the probability of getting into Cornell times the probability of Ithaca is the same as the probability of getting into both Cornell and Ithaca. So they've told us Cornell's chance of getting in, 30% of the people get in. At Ithaca, 60% of the applicants get in. And of the people that apply to both, 25% get into both. So does 0.3 times 0.6 equal 0.25? 0.3 times 0.6 is 0.18, which does not equal 0.25, which means these events are not independent. If those two probabilities had come out to be the same, then the two events would be independent. So in other words, there's some sort of relationship going on between Cornell and Ithaca that the getting into the both of them are somehow related to one another. Let's move on to Chuck and Donna and their viewing of the top 100 American films. And we're testing to see whether Chuck has seen the film and Donna has seen the film, whether those are independent events. So let's do the first method. Probability of Chuck seeing the film times the probability of Donna seeing the film. Is that the same as the probability of Chuck and Donna both seeing the film? So from the two-way table, we're going to gather up these probabilities. The probability that Chuck has seen the film, in other words, he's seen 25 of the 100 films, so the chance of us picking a film that he's seen is 25 out of 100. And then the probability that Donna has seen a film, one of the 100 films, is 60 out of 100. She's seen a lot of them. And we want to see if that's the same as the overlap of Chuck and Donna. Here's Donna. Here's Chuck. They overlap at 15. Out of 100. And believe it or not, when you multiply 25 100ths times 60 100ths, we get 0.15, which happens to be the same as 15 100ths. So these two events, Chuck seeing the film and Donna seeing the film, are independent events, because the probability of C times the probability of D is equal to the probability of both. Now I'm going to demonstrate how you could do this with your conditional equation. Does the probability of Chuck seeing the film, given that Donna has seen it, equal the probability of Chuck seeing it? So according to the two-way table, we are given Donna. There you go. She has seen the film. So there's 60 movies that she has seen. What is the probability that Chuck has seen one of those films? Right here, 15 out of the 60. So probability that Chuck has seen a film, given that Donna has seen it, is 15 out of 60. And now the probability that Chuck has seen a film is back over here, 25 out of the 100 films. And you could check to see whether this is equal by cross-multiplying, or we could change these into decimals. This is 0.25, and abracadabra, so it's 25/100. So again, the two probabilities are the same, so the two events are independent.